My name is Reinier. Talking about my background, I had a company for agricultural automation in the US. I recently moved back to the Netherlands and am now advising companies about irrigation and agriculture with IoT. You may ask, why have you industry knowledge? I was a wine growing farmer for 12 years in the US. So with that, I like to ask you to understand what it means to be a farmer. And just imagine it's the start of the day, it's 5 a.m. early in the morning, and your team comes together, here they are, and they basically look at you for the things to do, the job tickets for today. So you want to make sure that you cover the urgent repairs first. Then irrigation, spraying, anything that needs to be done on the farm needs to be assigned and planned. So for a system to support you, you would need instantaneous information about what needs to be done, where and when. Now, if you get this information and the people get their job tickets, please understand that getting the information instantaneous and clear is something different than giving a farmer data from sensors. So he needs to have condensed information about what needs to be done when and where. But now the thing is, and I've looked around at the Congress, there's a lot of companies doing sensors. There's not a lot of companies that are doing the actuator control. And this is where half the solution comes in, and actually where most of the profit of an automated solution using IoT is coming in. So if you can add automation control to the information that you want to do, you can optimize water conservation, you can reduce labor cost, which is, by the way, the highest cost. And you can basically use your resources much more efficient. And we're talking about fertilizer, we're talking about herbicides, things like that. This will also help create sustainable practices. If you know what you're doing and you keep a record of it, you can repeat it. And in that process, you can improve your results. Now, to give you an idea what economic results will mean for a farm, so this is an example for grape growing. So if you can save 20% water per year, it would mean $156 per acre on average, which is okay compared to the investment that you need to do. But if you think about labor, you see that if somebody needs to drive out to the field, open valves, come back later to close them again, that's a lot of labor. Labor is hard to get, like water. But if you're asking a farmer nowadays, what is keeping you awake at night? It's going to be, depending on the farmer, water, labor, labor, water. That's basically it. And of course, also the effects from climate change, but that comes at a later point. So what are the advantages of automation and basically also having the correct information to make the right decisions? It's basically, you can save on your labor, but also by improving your process and having better control of how much you irrigate, how much you fertilize, what you do when, if you have a problem with insects, that would basically help you increase your fruit health, so you can get a higher price for your fruit, but also you can get more fruit per acre. So that would mean additional income as well. So for a farmer, it's not just having information, it's also what do you do with it that gives him the economic benefit and also makes him understand that maybe investing in this technology is a very good idea for him. Now, what does this system look like? This is a very generic picture. Most of you have seen this, but I just want to share it real quick. So you have the sensors in the field, they report to the LoRa gateway, it gets collected on the internet, on the cloud, and there's an application that basically condenses the data into useful information. Again, the farmer doesn't want to have graphs for each and every sensor. He wants to know what does he need to do in that particular field on that day. And that needs to be connected to an automated system that basically puts it into action. So to put things into action, what do you need? You need to add some more components than just sensors. So we're talking about valves. Valves help you switch on water supplies, and also you can use a valve to basically add fertilizer. You want to keep track of how much you irrigate. So you want to have a water meter. Usually water meters have pulse output, so you want to count the pulses, so you know how many gallons you have dispersed on that field. And then if you want to make a luxurious solution, you can opt to use an injection pump. So you can use the irrigation system to spread fertilizer or insecticide if you have a problem with that. Compare that to the cost of driving a tractor through the field and spreading that material in the field. Now you can make economic use of an existing irrigation system to basically distribute. So, to give you a little idea, you need to do things in a certain sequence. If you want to add fertilizer to your irrigation system, let's talk about the sequence here. So you need to start irrigation first. You need to fill the lines, which can take several minutes, with water. Then, depending on what kind of fertilizer you have, you need to mix it. Some fertilizers, especially the biological ones, have a tendency to basically sink down to the bottom. So you mix them all up, and then you can basically start injection in the irrigation system. Now, once you reach the point where you have distributed all you wanted to distribute for that day, you stop the irrigation injection, but you still need to flush out. You need to clean the irrigation system. Especially if fertilizer stays in the irrigation system, it's going to cause trouble, it's going to clog up the drippers or whatever you have. So you want to clean it out. Here you see an example of a system that does that. So the blue unit is the pump, and then there are two boxes. One is controlling the irrigation, and the other one is controlling the fertilizer injection. The irrigation system can be in Class A, LoRa Class A. For the fertilizer, we usually use Class C because it needs to be synchronized with the irrigation. That's the reason why. Here you see an example of a plumbing layout. I wanted to call this a flow diagram because it shows the water flow, but I'm pretty sure that has a different context here sometimes. So what you see is water is coming in at the manual valve on the left side. It goes through the flow meter via a filter. And here you see that the fertilizer control also controls a master valve. So what happens in this case, this is a pump that works on hydraulic power. So you don't need power in the field. It doesn't need any electric power at all. So it's ideal for in the field applications where you don't have power. In the case of just irrigating, the water flows from left to right, and it goes through that filter to the irrigation controller. And here you see that this is an irrigation controller which can control 4 valves. So you can select 4 fields. And by bypassing the master valve in the middle, you can basically close it. Or by bypassing it, the water goes straight to the irrigation. By closing the master valve and opening the 2 pump valves left and right of it, the water is forced to go through the pump before it goes to the irrigation system. So that's how you can basically divert the water to go through the pump. And by controlling the valves, you basically control the injection of the irrigation. So wrapping up, I think what I wanted to bring as key takeaways for this short talk is that instant access to actionable information is important, but it's basically also the start of it. In my practice, I know that farmers don't have the patience to wait for data to come up. If data needs to be already compartmented in the application to be ready available. If you want to see what the soil moisture was from last month and it still needs to be pulled up from the system and it takes a minute, the farmer is already talking with his people. He's not waiting for it. So it needs to be instantaneous for farmers' acceptance. Now, I hope I've shown that an integrated system which has information from sensors, but also the actuator component, will bring real benefits in water conservation, labor conservation, but it also gives you more control over resources. If you think about fertilizer, you know that the fact that you need to take a tractor and run a pump, it's basically taking a lot of labor and also time. And now you only will do it only 1 or 2 times per year because of that. Now you can basically automate it, so you can run fertilizer every day. So you have more tight control over the fertilizer. And last thing, I think other speakers had talked about it too. Every installation, every project is different. It's no different for farms. Every farm has its own irrigation system requirements. So make your system flexible and adjustable. All right. With that, I'm open for questions. Yes, sir. I can't hear you, sorry. I can come to you. Yes, sir.
In your system, oh, thank you. In your system, did you have any feedback from the field, how much water was going in, how much fertilizer, etc.?
Yes, that's basically using the water meter. And then the pump that I was showing, so I'm not promoting any specific products here, just to make sure, but that pump has a calibrated dilution rate. So 1% of all the water that is going through is...
But I mean in the field itself, in the soil, by the plants. Do you measure that?
No, you don't need to in practice, because every dripper is calibrated, so it's 1 gallon per hour, and if you have 2 drippers per tree or plant, you know exactly how much. Another thing, and that's an important thing regarding your question, you need to make sure that your irrigation system distributes the water evenly. If you're laughing, I had a 20-year-old system, and it had an efficiency of about 60%, meaning some parts get more water than other. So we had to refurbish the whole irrigation system in order to get it 95% and up.
Okay, thanks.
Yeah. Yes, sir.
Hello. Thanks for the presentation, very interesting. How do you adapt a use case to farmers who already have, I would say, a good irrigation system, fertigation system installed, but that want to automate? And sometimes these systems are not fully open, so I don't know if you had the case.
Well, I'm losing contact here. Oh. So, with existing irrigation systems, you have manually operated valves. These valves can be replaced, and in a lot of cases, the valves can, if these are valves that have a battery-operated timer, you can easily replace the battery-operated timer with a valve that can be actuated through a controller, a LoRa controller. So that's the way to do it. And then depending on what kind of fertigation system they have, yeah, it depends on it's very location specific.
Thanks.
Yeah. Any more questions? Great. Oh, one more. Oh.
Hi. Hello, thank you first for the presentation. Do you have in your system an integration with other systems that collect like weather data or something like this?
Yes, you need to. So in order to optimize the irrigation amount and the time when you need to irrigate, you need to know how much water your plants are using on a day-by-day basis. So you can use satellite data, you can use weather station data to calculate that. All right. Thank you.